All right.
So starting on 3, I think, yeah.
I had a plan for tonight if you didn't have any homework, and
Oh, okay.
that was to start you on ACT. You're a sophomore, right, Dylan?
Yeah.
Are you taking a practice ACT anytime soon?
None that I know of. Yeah, our teachers haven't told us anything about that.
All right. Well, the beauty, the ACT is going to be extremely important to you. You will take it probably when you're a junior and for the last time maybe in the fall year of your senior year. But it'll make almost as much difference as your overall grade point average will. So it's extremely important to do good on it. And it's only algebra and geometry. So when I'm teaching somebody basic math, I love to use the ACT because it covers the most important stuff from algebra and geometry.
Okay.
As opposed to your geometry course, which covers maybe 2 or 3 times more than that. There's a lot of things you get in geometry that you're never going to really have to know again. And so if we want to refresh your geometry skills, there's nothing better than the ACT. So even if you have nothing to work on, we'll always have the ACT because I have 6 practice tests on my computer. And so we have no limit to the problems we can do. But if you want to work on your basic math skills, I always have material.
Okay, cool.
All right. Okay. So let's look at this. Still getting a little used to
Windows.
Snap left. No, see, it didn't really do it. What happened? I want this to snap right. All right, now I got it. So where are we starting here? Number 1?
All right. Number 3.
All right.
Yeah.
Let me see if I can draw what I think I see here.
Cool.
First of all, it's a right triangle.
Yeah. Or actually, no.
That means we're not going to use the law of sines or the law of cosines. Now, I realize that these notes across the top don't necessarily apply to these first 3 problems.
No. And then...
Go ahead.
Yeah. We're starting on number 3, like, part 2, my bad. It's, because, Mr. Magus checked it and said it was all correct. So my bad.
This one here. All right.
Yeah.
And that does require the law of sines.
Yeah.
In other words, as soon as you get beyond right triangles and you start talking about triangles like number 3, what's that angle? The top one?
Yeah.
That's 70?
70 degrees, yeah.
All right, let's go ahead and finish labeling.
Okay.
The angle here. Always do what you can do immediately.
Okay. Cool. So we know that, 34. Okay, so we can do sin 54 over b.
The easiest way to solve for a third angle is to just use the fact that the sum of the angles is 180. So what's 180 minus 124?
Oh, let's see here. 56.
All right. So now we know that.
Mm-hmm.
Okay. And now
Cool.
the question is to solve for side. Oh man, they've labeled this funny. It's rare that you see it labeled counterclockwise. Usually it's labeled clockwise.
Yeah.
But it doesn't matter. This is side little b. This is side little a.
Yeah.
And so here's a triangle that's not a right triangle. And there's two choices. We can either use the law of sines or the law of cosines.
Okay.
From your notes, it looks like you've used or learned the law of cosines, and that's part of what you're going to need to know. The law of sines is the one that's used most frequently.
Okay.
And it's the simplest. And what it basically says is that within any triangle, right triangle or not, but particularly not right triangles, the sine of any angle, let's take that 56-degree angle,
over A, right?
over A,
okay, is equal
to, and is there any angle opposite side relationship that is complete?
C.
Yeah, so that has to be equal to the sine of 70 degrees over 34. Okay.
Cool.
Now, you only have one unknown there. In other words,
Yeah.
that's a number, that's a number, and that's a number. So by cross-multiplying, you can solve for A.
Okay.
Do you have a
Do you mind if I... Yeah, I was just going to go. I got humps.
Get
I
calculator, and let's do this. Let's make sure.
Okay. Okay, let me go grab that real fast. I'm sorry. I got home at 7:56, and then
That's all right.
everything.
That's all right.
All right, hold on. Okay. To 95. Okay, got it.
All right, now let's talk about this equation for a second.
Okay.
I never like when my variable is in the denominator.
Yeah.
Only because it's two steps instead of one step. Okay?
Okay.
And the law of sines does not care if you put the sign in the numerator or the denominator as long as you're consistent. In other words, it's also true that A over sine A equals B over sine B equals C over sine C.
Okay.
Okay? Which means that let's take this equation we have and make it A over sine 56.
Is equal to 34 versus
Yeah.
Okay.
And I guess that's a step that we didn't absolutely have to take. But now you do not solve this by cross-multiplying. You solve it by multiplying both sides by the sine of 56 degrees.
Okay. So we would use sin 56
One
times
step only. When the variable is in the numerator, is all I have to do is multiply by the sine of 56, both sides.
Okay.
And here is my answer. Whoops. Not that 34, but There, the bottom part. So
Oh,
it's always easier when the variable is in the numerator because it's one step instead of two. Don't
yeah.
don't automatically cross multiply. Sometimes you don't
Okay.
need to.
Okay.
And it's important to understand that this law of sines works both ways, with the reciprocal or not.
Okay.
Now, in this case, we were solving for side B. I didn't look at this closely enough. Usually when you have these kind of triangles where they give you three pieces of information,
Yeah.
two angles and a side, well, it's not a question of solving for one side. It's a question usually of solving the entire triangle. Let's figure
Okay.
out all three sides and all three angles.
Okay.
So how do I solve for B?
So to solve for B, you would do 34 times sin 56 divided by sin 70.
Hold on.
Okay.
34 divided by sine. It's
My bad,
actually
yeah.
spelled like that.
Okay.
Okay?
Okay.
It's shortened to three letters. And
Okay.
that's why I have a lot of students that say sin, because that's what they are reading is the word sin. But it is sine. Okay?
Okay.
So it's the sine of 70 degrees, and that's the relationship for this triangle.
Okay.
That always has to be true regardless of which angle or which opposite side you're talking about.
Yeah.
And since we're solving for B, what's the rest of it?
So since we're solving for B, 34 over sin 70 is equal to just sin 56, right? Or
Hold on, we're solving for B. What's the opposite angle to B?
sin 54.
Okay, so it's B divided by
By
sine
sin
54.
54.
Okay,
Okay.
now I set it up this way where I had, now make sure you understand the difference between a side length and an angle.
Okay.
Every angle has an opposite side, regardless of how you draw the triangle. And the law of sines is all about that relationship.
Yeah.
Whatever an opposite side is relative to the sine of the angle, that is a constant, regardless of which angle and which opposite side you're talking about.
Okay.
So now it's easy to solve for B. It's a one-step solution.
Okay.
Solve that. What's the next step?
So you would do 34 times sin 54?
Sine.
Or sine, I'm sorry.
I'm going to correct you every single time until you get it right.
Okay.
All right? I hope you don't
So,
take offense at that.
no, not at all.
Okay.
So I got 2750.
All right. And that's your answer for 3.
Okay.
Now, yeah, it's always a good idea when you get your answer to write it in there, 27.5. And the reason is that sometimes a lot of things can go wrong. You can have your calculator in radian mode and you thought you were in degree mode.
Right, yeah.
And if you make that mistake, it will make gigantic consequences. You will end up with numbers that are way out of the range that they can be in. Now,
Yeah.
does this number make sense?
It does, yeah.
Why?
Because the other side length was 34, which was the longest one. It just makes sense that B would be 27.5 because it's less than AB.
Okay. Is side A going to be less than 27.5, more than 27.5, less than 34,
Less than 34.
and more than 27.5?
Yeah.
because it's the middle angle.
Mm-hmm.
The middle angle has to be opposite the middle side.
Okay.
So this side A will be between 27.5 and 34.
Okay.
All right.
Cool.
So, number 4 next.
Yep.
Again, a non-right triangle.
Mm-hmm.
All right triangles, you do not use the law of sines or cosine.
Okay.
Okay, just remember that.
Okay.
You only use the law of sines or cosines when you have non-right triangles.
Okay.
We could figure out that angle right there, but they don't ask for it. They only ask you to solve for x. So they're not asking you to solve the triangle. How do we solve for x?
So we would do sine 60, or x over sine 60.
There you go. That was a good first step.
Cool.
Make sure your variable is in the numerator if you have a choice. And you do have a choice on these.
Uh-huh. And then is equal to sine, or is equal to 50 over sine 45.
Make sure you don't switch it. That's the biggest danger.
Yeah, definitely.
In other words, if you had sine 45 over 50, you'd be screwed.
Wrong answer. Yeah.
Yeah, you have to make sure that the top is the sides in both cases. These can be either way, but they have to be the same way.
Mm-hmm.
So what's x?
So x would be, would we just do, 50 over sine 45 times sine 60?
You got it.
Okay, so we would do times sine 60. I got 61.23, so just round down to 61. So x would be 61.
Give lengths to the nearest whole number, angles to the nearest degree. What was it? 61 point what?
23.
Okay. All right.
Cool.
So 61 is correct, and that makes sense. At least it's larger than 50.
Uh-huh.
Okay.
Exactly. Cool.
What kind of calculator are you using, Dylan?
Just a graphing calculator.
Which one? Is it the TI-84 or the Inspire?
I think it's the TI-84.
All right.
Yeah. I think it's the, cheaper one.
Well, they just haven't forced you to upgrade yet.
Yeah.
I bet you they do before you graduate from high school.
Oh, definitely.
Maybe,
Yeah.
maybe not. I mean, they tend to force sophomores entering now to get the TI Inspire.
Uh-huh.
It's a radically different operating system that takes some use.
Oh, yeah.
Used to.
Lots of practice, yeah.
Well, it's just different. It's a lot different than the TI-84, and you just have to get over that learning curve.
Yeah, I mean, like with my friends that are in Algebra 2, they had homework just to practice using it. Like that was their homework, was just to like figure out how to use everything on it. But
they almost need to give a class on how to use the Inspire.
I totally agree.
It's
to get that.
Definitely different.
Yeah, for sure.
All right, with this problem, we want to find area.
Mm-hmm. Okay.
What's the general formula for area when you know angles?
Like just like of a triangle?
Yeah.
Just based on...
With a normal triangle, it's 1/2 base times height.
Yeah.
But with non-right triangle, in other words, we don't know how to find the height on this this triangle.
Yeah.
Right? So there is a special formula in trig that allows you to calculate the area of a triangle.
Yeah.
And I use it so seldomly that I don't have it memorized.
That's okay.
Here, I'm trying to look it up. Go to my index here.
Cool.
That's why I asked you if you knew it, just in case you did.
Yeah.
And I wouldn't have to look it up. Area of a triangle, 464. Alright. It is.
Okay.
1/2 BC times sine of A, or 1/2 AC times the sine of B. And notice the difference between the designation for side lengths and angles. Angles are capital letters, side lengths are small letters.
Yeah.
And it's also equal to 1/2 AB sine of C. And notice the pattern here. In other words, these are two sides, this is the third angle.
Okay.
Two sides, the third angle. Two sides, the third angle.
Okay.
Okay? And all of these are equal to area. So, what do we have here? We have certainly two sides.
Yeah.
What's the third angle?
So we can do 120 plus 25, subtract that from 180 to get the third side. So we would have...
Well, hold on a second. This is
Okay.
side B.
Yeah.
This is side A. And this is side C.
Okay.
What two sides do we have?
We have side B and then side C.
No.
Or angle C and then angle B.
Hold on. We do have angle C and we have angle B, but what two sides do we have?
We have side AB and then side BC.
Hold on. We have side C.
Oh.
And we have side
Oh, because it's the opposite, yeah.
Exactly.
Okay.
The little a is opposite big angle A, and the little c is opposite big angle C.
Okay.
Okay? So we have C and A, so we're using that, and we also have the sine of B, or we have angle B.
Yeah.
So what is the area of this triangle going to be?
Let's see here.
Plug everything you know. In other words, use that formula, and you know A, you know C, and you know angle B. So plug it in.
Just sine.
Start with the number.
Yeah, so I got 0.5 half times 10 times 18 times sine of... What would the sine of be?
Well, what is angle B?
Angle B would be 35. Oh, no.
35 or 25? Looks like 25 to me.
Is it 25? Yeah, because 120 plus 25.
Let me erase my circle. It's 25 degrees right there.
Okay. So I got 38.03.
So you took the sine of 25 degrees?
Yeah.
And you got a complete answer of that number?
38.03564356.
I said round everything off to that.
Yeah.
Although, hold on a second, we're solving for side B, correct?
Okay, yeah.
No, hold on, which one are we doing? We're doing find the area. And they want you to round off to what? Give lengths to the, oh, interesting. Give lengths to the nearest whole number, angles to the nearest degree. Well, what about areas? That's not a length and it's not an angle.
No.
So I would assume he wants you to round it off to the nearest whole number. So the area would be equal to 38.
Okay.
Square, whatever. They don't
So,
put units on it. So,
yeah,
oh, yes, they do. Square centimeters.
Okay, 38 centimeters squared. Okay.
I see that.
Okay.
Centimeters there.
Cool.
Area is always in square something.
Yeah.
And, okay. So, these three equations work for any triangle. In other words, as long as I give you two angles and a side, I can use one of these three equations. And it doesn't really matter which one you use. In other words, I know the way we did it, we ended up using this triangle here, or that equation there. But notice is all we needed to do was find two sides. The two sides we had were 18 and 10. And the angle or the sine of the other angle. Well, the other angle is this one right there. So that's what each of these equations is saying, is that you take the two sides that you're given and the sine of the other angle.
Okay.
You know what I mean by the other angle? Angle A is the other angle, not B or C. And in this one, angle B is not A or C, and so forth.
Yeah.
All right.
Okay. Cool.
Let's look at 6. Now, sometimes they'll draw it like it looks like a right triangle.
But it's not.
Well, if they don't put the 90-degree thing there, it's almost never. You certainly cannot assume that it is.
Yeah. Yeah.
Now, notice what the problem here is. We cannot, we want to find area again.
Yeah.
All right. So to get area, we need two sides and the opposite angle. By the opposite angle, I don't mean the angle opposite either of the sides. I mean the third angle. That's what we're looking at here. Well, now hold on a second. Are we supposed to find the area for number 6, or are we supposed to solve for x?
I think we're just supposed to solve for x.
Yeah, I think so also, because this looks like a law of cosine problem.
Yeah. Yeah.
Now, we haven't done one of those yet. So let's talk about it. When do we use the law of cosines as opposed to the law of sines?
What's the difference between them?
Well, notice that in order to use the law of sines, you have to have one angle and an opposite side. Well, they've given us 3 pieces of information here.
Yeah.
They've given us side 11, side 13, and angle 40 degrees, but we don't have that relationship. In other words, I don't have any idea what that angle is or that angle.
Yeah.
So I can't use the law of sines, at least not to start with.
No.
Got to use the law of cosines.
That makes sense.
There's only
Okay.
two situations where you use the law of cosines to start.
Okay.
One is side, angle, side.
Mm-hmm.
The other is side, side, side. And that's it.
Okay. Yeah.
Only those two. If you
Mm-hmm.
have side, side, angle, or if you have angle, angle, side, any of those others, you never use the law of cosines. Only use it for these two situations. Well, notice
Mm.
that's exactly what we have is side, angle, side,
Yeah.
in that order.
Mm-hmm.
So if it's that, we're going to use the law of cosine.
Mm-hmm.
Now, here's what the law of cosine says. Do you know what it says?
The law of cosine, so it would be...
What is it? There's three of them. Just like area, there's three of them depending on which sides of the triangle you've been given. But in reality, there's only one. In other words, with
So would this
area, it was if you had two sides and an opposite angle, you could figure out the area. Well,
Yeah.
same with the law of cosine.
Okay. So this one would be the side angle side one, right?
Right?
Okay.
But what is the law of cosines? Here, let me write it for you.
Okay.
B squared equals a squared plus
C squared.
squared
Okay.
minus 2ac
Okay.
cosine of what? What's this last angle?
Oh, 40. Cosine of 40.
B.
Oh, just B. Okay.
Okay, hold on.
Okay.
I'm not done. There's the first law of cosines.
Okay.
Second law of cosines is
Mm-hmm.
very similar pattern. What's the rest of it?
It's equal to B squared plus C squared minus 2AB cosine.
2bc.
BC,
Whatever
my
these
bad.
two letters are, that's what's going to go there.
Okay. And then cosine C.
Whatever this letter is, that goes there, only capitalized.
Okay. Yeah, my bad.
See the pattern?
Uh-huh. Yeah.
Okay, so what's c squared, the third one?
So C squared would be is equal to A squared plus B squared minus 2AB cosine C.
Very good.
Cool.
All right. So, again, it doesn't really matter which one you use, but we're trying to solve for x, which is, in this case, that.
That one, yeah.
Okay. So,
Okay.
let's use that one. So, x squared.
So we would do x squared.
Hold on a minute. I haven't quite figured out. Just a second.
Okay.
This program doesn't give me quite the capability that my old one did.
It's alright.
So in this case, B, the side opposite capital angle B, that's B, x squared equals, fill in the rest.
So it'd be x squared is equal to A squared plus C squared, right?
What is A?
A's 11. A's 13. 13, my bad. Yeah. So it'd be 13 squared plus 11 squared minus 13 times 11 times cosine 40, my bad.
Good.
Cool.
Notice these are all numbers.
Uh-huh.
Nothing there is a variable.
Yeah.
So you can come up with x squared, take the square root of it, and you have your answer.
Cool.
Now, as long as we've gotten this far, let's get you an answer. Go ahead and do that.
Okay, I got 70.91, which will round up to 71.
Hold on.
Well, that doesn't sound right.
Does that make sense?
No.
Okay, so we did something wrong.
Let's try that again.
Why you do those tests. That's why I always do my ballpark test.
Yeah, because it definitely doesn't
You
seem right.
spot them.
Uh-huh.
First of all, that's not that easy to do on your calculator.
No, for sure.
There's a lot of steps there.
Yeah. Yeah.
You might want to do those two first, come up with a number. And
yeah, 13.
maybe do that one second and subtract this number from this number. And whatever you get, take the square root of it.
Times 11. Okay. What the heck?
A lot of times on these kind of problems in your calculator, I find it much easier to do it in stages.
Yeah.
In other words, rather than trying to figure out how to put that entire thing into your TI-84, and it's not even going to tell you if you got it in there correctly or not. It's just going to spit out a number.
I got 3.64.
3.64?
0.64, yeah.
That sounds almost too small.
Yeah.
Well, tell me what you get when you get 13 squared plus 11 squared.
Okay. I got 290.
And what do you get when you get 2 times 13 times 11 times cosine of 40 degrees?
So 2 times 13 times 11 times cosine of 40? Okay. 219.08.
So now subtract those two numbers, and you get approximately 71.
Yeah, 70.92.
The square root of 71 is what we want.
Oh, 8.42.
That number makes a lot more sense.
Yeah, for sure.
Just for your information, it's really hard to have two sides of a triangle be 11 and 13, and the other one be 3.
Yeah, it just doesn't make sense.
As big an angle as 40 degrees is.
Yeah.
That did not make sense to me.
No.
So sometimes you can be off by just a little bit, and you can still spot it by the ballpark check.
Yeah, definitely.
That number makes a lot more sense to me.
For sure, yeah.
And remember, you have to take the square root of it. Everything is squared here. In other words, in reality, b is the square root of the whole right side. But trying to put that into your calculator is like a nightmare. So, no, it really is.
It is.
Especially on the TI-84. One of the biggest improvements for the TI-Inspire is that it shows you what you put in.
Yeah, definitely.
So there's never any problem, whereas the TI-84 does not show you, and gosh, if you have a misplaced parentheses, you're in big trouble.
Yeah, definitely. Yeah.
All right.
Cool.
So that's where we use the law of cosines. Now, I'm actually amazed that you're getting the law of cosines.
Cool.
Just because that's not every geometry student gets the law of cosines.
Yeah.
Here's the only other, and incidentally, every time you use the law of cosines, to finish solving the triangle, which is to say all three sides and all three angles, you always have to use the law of sines.
Yeah.
Step 1 is the law of cosines, and that gives you an angle or a side and allows you to get that relationship between an angle and its opposite side. And then you finish the triangle by always using the law of sines. So there is no triangle that you would use only the law of cosines, unless it's these kind of problems. These
It's
kind
hard.
of problems are not solving the triangle. These kind of problems are solving for x, or
Yeah.
finding the area, or solving for x, or solving for b.
Mm-hmm.
But you're one step away from, when you take trig, the question is always solve the triangle. In other words,
Yeah.
solve for all three sides, all three angles, which you
Mm-hmm.
can always do given just three pieces of information. In other words, I
Mm-hmm.
have two sides and one angle here. That's all I need. I'm going to be able to solve that whole triangle.
Okay.
Okay? And
Mm-hmm.
let's talk about, I'm going to make up a problem here, but let's talk about the only other situation where you use the law of cosine.
Okay, cool.
I have no angles, but I
Mm-hmm.
have three sides.
Mm-hmm.
Okay?
Okay.
So I can pick any of the three equations that I gave you. Well,
Okay.
I'm going to use a squared.
Mm-hmm.
A squared equals what?
A squared is equal to b squared plus c squared minus 2 or minus 2 bc times cosine of a. Or sine of a, my bad.
Oh, you were correct. I wrote it wrong.
Mm-hmm. Cool.
So let's fill in everything we know.
Mm-hmm. So we know that
Let's
uh
a squared.
7 squared.
49.
Yep. So it'd be 49 is equal to
B squared.
yeah, so 64 plus 36 minus 2 64 or minus 2 times 8 times 6. Wait, yeah.
Cosine, and notice we do not know what a is.
No.
That's the variable. That's the only
Mm-hmm.
variable in this equation.
Yeah.
Everything else is a number. So we can solve for the cosine of a, and meaning we can solve for that angle a.
Yeah.
Okay, let's do it. So if
Okay.
we do the arithmetic here,
Mm-hmm.
subtract 100 from both sides,
Mm-hmm.
which means the cosine of a equals positive 51 over 96. What is that number? What is that decimal? Actually,
Oh.
how do we solve for angle A, given that cosine of A is equal to 51 over 96?
Ooh, so we would do cosine negative 1.
That's called inverse cosine.
Inverse, yeah. So we would do
We would take the inverse cosine of what?
0.531.
Okay. And that's equal to angle A.
Which is 57.92 or 58.
All right. So now, notice that if you told me the problem was to solve the rest of the triangle,
Mm-hmm.
because I've been able to solve for one angle,
Mm-hmm.
I can now use the law of sines to solve the rest of the triangle.
Yeah.
In other words, I have an angle and I have its opposite side.
Okay.
So now I can say that angle C,
Mm-hmm.
sine of C over 6 equals the sine of 58 degrees over 7.
Yeah.
That will allow me to solve for angle C.
Okay.
Once I've solved for angle C, it's easy to solve for angle B just because the sum of the angles add to 180. So you actually
Yeah.
don't even finish it with the law of sines, although you could, but So when you start out with a problem like side, 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 use the law of cosines as the first step, then use the law of sines as the second step, and then use the fact that the sum of the angles is 180 degrees as the third step.
Cool. All right, cool.
All right. I'm not even positive that they gave you a problem like that.
Yeah.
Because this is the only law of cosines I see on here, unless one of these word problems is also law of cosines where it's side, side, side. But
Yeah.
all right, let's talk about word problems.
Okay, cool.
They are more difficult, yes or no?
A little bit, yeah.
Just a very little bit.
Yeah.
In other words, every one of these word problems is going to translate to one of these drawings.
Exactly. It's just a matter of finding where everything
it's a
goes.
matter of drawing it.
Yeah.
So, when I'm done reading this problem, I'm going to draw a triangle, and we're going to have either two sides and an angle, or we're going to have two angles and a side, or something like that.
Okay.
So first of all, understand that. And these problems are not any more difficulty at all.
Mm-hmm.
So let's read it. When an advertising blimp is directly over one end of a football field, well, there's the football field and there's the advertising blimp.
Cool.
The angle of elevation to the blimp from the other end of the 300-foot long field is 78 degrees.
Okay.
That angle is 78 degrees.
Okay.
It's the angle of elevation. It's also the angle of declination or depression if you're measuring it from the blimp. In other words,
Okay.
that angle there is also 78 degrees. So if the blimp was measuring it, they'd come up with the same angle.
Okay. Cool.
What is the altitude of the blimp? We'll call that y.
Mm-hmm.
Now,
So could we do,
hold on.
well, we don't know if that's 90 degrees there, right?
Ah, there we go. This is a right triangle. I was trying to figure out how we're going to solve this because they only gave us two pieces of information. But in reality, they gave us three pieces.
Yeah.
The right triangle. So, what do we use to solve this?
Law of cosine, or law of...
Never law of sine or law
Sakatoa.
of cosine. We use your basic trig functions.
Okay.
What trig function relates that angle, that side, and that side? Think of your three basic trig functions.
Sin, or sine, cosine, or tangent.
Okay, which one relates those, mainly these two sides here?
Okay.
What, to this angle? Sine and cosine require the hypotenuse. We don't have any information about the hypotenuse. So which one deals only with the opposite side and the adjacent side?
OA, so tangent.
Okay, so give me the equation I can write.
So we would do tangent 78 times 300.
Equals what? Not times.
Oh, my bad, yeah. Is equal to 300 over y. Or y over 300, my bad.
Always go back to this.
Yeah, Sakatoa.
You're going to need that for 3 years.
Yeah.
Which means y is equal to 300 times that. I just didn't want you to get ahead of yourself.
Yeah, yeah.
Right? And that's a number. All it is a number. And that will be the altitude. If you want to come up with that, let's do it. So you have your homework.
Okay, so 300 times tangent 78 is equal to, so I got, oh crap.
Sounds like a number that doesn't make sense.
It really, 1,411.38.
Does 1,000 what?
100, or 1,411.38.
What's this angle right here?
Which one?
The one I'm pointing at.
Which one are you pointing at?
The other acute angle.
Oh, the other acute angle.
We're just trying to figure out whether that answer makes any sense or not.
It doesn't, though.
Well, yes, it does. But first
Does
of
it?
all, before you know that it does make sense, you need this other angle.
Yeah.
What is it?
Complementary
Complementary to 78.
Okay.
12.
12.
Complementary means the two of those angles have to add to 90.
Mm-hmm.
Now, we have 300 opposite a 12-degree angle.
Mm-hmm.
We have 1,400 opposite a 78-degree angle. That does make sense.
That does, yeah.
Yeah.
Uh-huh.
It's the only thing that doesn't make sense is the way I drew it.
Yeah.
But when I drew it, I never draw it to scale. I'm just drawing it to get a basic picture.
Okay.
But I'm never going to make sure that I draw that 78 degrees. In reality, this thing looked more like this.
Okay. Cool.
So that's 78, and that's 12, and that's 300, and that's 1411.
Cool.
Makes perfect sense.
Yeah, definitely.
Okay? So, let that be a lesson, that the way you draw it isn't necessarily going to be what causes it to make sense or not.
Yeah. Okay.
From the top of a cliff, a barge is spotted in the middle of the river 2,000 feet from shore. All right, here's our cliff. Here's the barge in the river.
Okay.
Presuming the cliff goes like that, and that's where the river starts.
Yeah.
That's 2,000 feet.
Uh-huh.
The angle of depression to the barge is 8 degrees. Again, I don't care whether I'm drawing it to scale, because you can't start out your drawing and then draw it to scale. You know what I'm saying? In other words,
Yeah, definitely.
I drew it, and then they tell me 8 degrees. Well, I can't draw an 8-degree angle. But
No.
it doesn't have to be to scale. We're not going to solve it by looking at it. We're going to solve it by using the law of sines or cosines, or more typically, a right triangle.
Yeah.
These things are always right triangles. Most all word problems are right triangles. Some aren't, but most are.
Mm-hmm. Yeah.
So, how high is the cliff? Again, I use y, not x, because x I like to use for horizontal measurements, y I like to use for vertical measurements.
Cool.
So again, give me the trig equation that's going to allow me to solve for y.
We'd still use tangent.
Always start out with the trig equation. In other words,
Yeah.
never start out with y and 2,000. Always start out, figure out which trig equation you need to use, and start that out on the left side.
Okay.
So you're correct,
So,
it's tangent.
yeah.
So what is the equation?
So it'd be tangent 8 times 2,000 is equal to y over 2,000.
Yeah, never skip that step.
Yeah.
which makes y equal to 2,000 times the tangent of 8 degrees, which is going to be a relatively small number, but what is it?
I got 281.08.
What's this angle over here?
Do we know that angle? 78 degrees.
The right triangle.
Yeah.
It's complementary with 8 degrees. What is it?
So it would be 92.
92 and 8 adds to 100.
Yeah, so it'd be 82, my bad.
Right?
Cool.
Now, you've got 281 opposite an 82 degree angle, and 2,000 opposite an 8 degree angle.
Yeah.
Does that make sense?
That makes sense, yeah.
No. Always remember, the longest side has to be opposite the biggest angle. We got it in reverse.
Okay. Yeah.
So what was wrong with our equation? First of all, let's go back to the beginning.
Yeah.
What's the tan of 8 degrees equal to? Is it y over 2,000?
Is it 2,000 over y?
Yes.
Yeah.
Aha. By doing our ballpark check, we picked up our mistake.
Yeah. Okay.
Which means y is equal to what?
Tangent 8.
Oh, you got to solve
Or y
that
is equal
equation.
to.
Got to solve that equation. You need to know how to solve that equation.
Okay.
Vital that you need to know how to solve that equation.
Yeah. So wouldn't we just do 2,000 divided by tangent 8?
Yep.
Cool.
What is that number?
And then I got 14,230.73.
It makes a lot more sense.
Yeah, for sure.
14,273?
230.
203. Okay.
Yeah, 230.73, my bad.
230.73
feet.
means it's 232.
Yeah.
For as far as your answer that you want to put on here.
Yeah.
Okay, so there was an excellent example of where we made a mistake in our equation and we caught it because the answer didn't make any sense.
Yeah.
It was the smallest side.
Yeah.
So, all right.
Cool.
These are good problems.
Yeah, definitely.
We didn't quite finish them, but we came close.
Yeah, we only have 2 more, so
yeah.
Thank you for that. Yeah.
Welcome. I guess we can finish them. We'll have some more sessions this week. So.
That sounds good, yeah.
All right, Dylan. Have a good
night.
And let's see.
Thank you.
Just check before I let you go. Let's
I think I'm
double
tomorrow.
check when your next session is.
Okay.
It's actually Tuesday at 8.
Okay, cool.
Tuesday and Wednesday.
All right, that sounds good.
All right. Talk to you then.
All right. Sounds good. Thanks, Mr. Cowan.
All right. Bye-bye.
All right, bye-bye.